Hello, and welcome to this video presentation. My name is Paul Brett. I'm a Senior Software Support Analyst supporting the IBM Transformation Extender product. Today's topic is using the ITX 10.1 ODBC adapter on Linux. Feel free to follow me on Twitter at Paul Brett IBM. For today's demonstration, I'll be using a simple map with a single input card using a blob type tree and a single output card using a blob type tree. On the input, I will be reading my query. On the output, I have a DB query function that uses that query information along with the connection string that you can see on screen in purple. Underneath, in red, I have the link that you can go to on Microsoft.com, which details how you can download and implement the ODBC driver for SQL Server on Linux. There are three simple commands which are listed in black below: a curl, an export, and a yum. I will also be making two updates to two files that come with the ITX 10.1 installation in the unixODBC directory. The first file is odbc.ini, and I will need to put in a stanza to point to my ODBC database. The second file is odbcinst.ini, where I put in the trace options as well as point to the SQL Server driver file that has been installed in the previous step. Okay, here we have a new Linux installation. And as you can see, if I go to the opt directory and into IBM, there is currently no ITX software installed. If I return to my user's home directory and into downloads, you will note that I have a tar file. This I have obtained from IBM Downloads, and I've used the gunzip command to work on the gz file that came and created just a tar. So the next step is to install the ITX software. So I'm going to go to the location where I want the software. I'm going to make a directory for it and go into that location and then use the tar command to extract the previously obtained tar file. When the extract is finished, if I list the contents of the directory, it is a standard ITX 10 installation. I can run my setup script, and in fact I can also now run the command server. It's fully working and ready to go. Okay, if I change back to my user directory and into a subdirectory I've prepared called maps, you will see that I have one compiled map, test1.mmc, and one input file. In the input file we have our query, and it's select star from test1. It's expecting a table called test1 and it's going to show all the contents of it. If I try to run this map now, you will note that it will fail. We see on screen an exit call failed string that tells us that the DB query went wrong. I hadn't actually got my DB query wrapped in a valid fail pair, so the map itself did not fail. However, let's look at the content of the output. Failed to connect to the database. That's the output from my last error message function. And if we have a look at the DBL file, you will see that it is saying that the unixODBC Driver Manager is saying that it cannot find the data source name. So we may need to make a couple of edits to the odbc.ini file and the odbcinst.ini file to be able to, for the map, to be able to find that database. So let's do that now. Let's go to our product installation directory, and you will note that we have a unixODBC directory. Within there we have an ETC, and this is the location we will find the odbc.ini and odbcinst.ini files. If we have a look at the variables that have been set and grep for the string ODBC, you will see that there are two variables that also point to this location: ODBC ini, which points to the ODBC.ini file, and ODBC sys ini that points to the directory where we can find both the files. Okay, so you will note that the two files as they are delivered from IBM are both 0 bytes in size. I'm going to copy in a replacement ODBC and ODBC inst.ini files from a backup I've made, and then I will show you the edits to those that I made. Okay, if we look at the content of my directory now, you will see that both the files have content, 80 bytes and 212 bytes. So let's start with the ODBC inst.ini. So we have the ODBC stanza, which is required and includes the file values that you put in to enable or disable the trace. So I have turned trace on with a yes, and my trace location is writing to a file in my logs directory of my ITX 10.1 installation. I've also put in a driver stanza, and I've called it ODBC Driver 17 for SQL Server. It has a description. This is optional, but it's always handy to pop that in. And then it has a driver pointer, which is pointing to a file that is obtained from Microsoft. This file does not exist yet. We'll come back to that later. I'll show you the edits I made to the ODBC.ini file. I created one stanza for my ODBC data source. I've used exactly the same stanza name in my ODBC adapter connection string in my map. It has two lines. The first line is a string that points to the driver. That string has to match the stanza that I've just shown in the ODBC inst.ini file. And it has another line that says server equals, where I have an IP address and a port number for my SQL Server instance. Other options are available, such as SSL encryption options, but I'm just going for the basics here. Okay, let's go back to my maps directory, and we'll remove the output file and the database trace. So we're back to just our input file and our map, and let's run the map once again. The map is still succeeding. The exit call is still failing, and we have a different error message in our DBL file. Let's show the output file first. Still failed to connect to the database, and then let's show our DBL file. Now it has found the VM16X SQL stanza, and we've no longer got the cannot find stanza error message from the previous run. This time we have a cannot open lib message, so it's asking for a driver that currently does not exist. So the driver from Microsoft needs to be installed. As I said, there's a web page where these instructions can be found. There are 3 simple commands if you're running Red Hat 7, which I am here, and these commands have to be run as root. So I'm going to be changing to root now, and I am going to be going to the root home directory where I have the 3 commands stored in a script for ease. So I'm going to show you the content of the script is the 3 commands that I mentioned previously. It's a curl, which will go off and actually get the package. There is an export of a variable to accept the end user license agreement automatically, and then finally there's the yum install command to actually install the driver in the correct place. So let's kick this script off now. The driver has been downloaded and it's asking me if I want to install it. I'm going to go with yes, and that's complete. If I go to my opt directory now, you will note that as well as an IBM and an RH directory, I now have a Microsoft directory. If I go in there, we have MS ODBC SQL 17, and if I go in there I have a lib64 directory, and within there is the actual driver itself. Now this is the location that I'm pointing to in my ODBC inst.ini file that we edited earlier. So in theory, if we exit out of SU and we go back to running our map again. I'm going to remove the output. I'm going to remove the trace. We've just got our map and our input file. I run the map one more time. Oops, capital T, please. This time we do not see an exit call failed. We still have a map completed successfully, and if we check the contents of our output file, you will note that we have the contents of my database table. So there it is in summary. This is the steps you need to integrate ITX 10.1 using the ODBC adapter through unixODBC to an ODBC driver supplied by a third party to be able to connect to an external database, in this particular instance Microsoft SQL Server. I want to thank you for taking the time to watch my video presentation today. If you found the content interesting and informative, please hit that like button. Consider subscribing to my YouTube channel as I release content such as this on a regular basis. Feel free to reach out to me on Twitter at PaulBrettIBM. Thank you.